Hi, in this video we'll be talking about, so we'll just be continuing with the C# tutorials. So we'll be talking about random number seeds. So quickly we'll just talk about that. So just have some notes down here. So random number seeds. So the numbers that are generated by the random class are not truly random. So if you want to get a random number, you obviously need a formula for it. But you can't just have any formula, because it won't be truly random. Well, it's not truly random basically, so the numbers that are generated by the random class are not truly random. Instead, they are pseudo-random numbers that are calculated by a formula. So it seems like it's random, but it's technically not. The formula used to generate random numbers has an element in the equation that's actually changing all the time. So the formula used to generate random numbers has to be initialized with a value known as a seed value. The seed value is used in the calculation that returns the next random number in the series. When a random object is created in memory, it retrieves the system time from the computer's internal clock and uses that as the seed value. So the system time is an integer that represents the current data and time down to the 100th of a second. So it's not completely random, because it uses the computer clock, which is changing, but technically there is, like, it could be a value of numbers, but depending on, unless you see the code or not, you wouldn't be able to know what the actual number is. Well, obviously there's a lot of different choices. But if it's like only 0 or 1, and you could figure out the 100th of a second, then you could probably get closer to the probability, but it's still complicated. So if a random object uses the same seed value each time it is created, it always generates the same series of random numbers. Because the system time changes every 100th of a second, it is the preferred value to use as the seed in most cases. However, you can specify a different integer value as a seed if you desire when you create a random object. So we could say, this is just basically the same thing we've already looked at, so this is just saying random rand points to new random. You could pass in here like some random number. So this would give you a value between 0 and 9,999, I think. Which would then incorporate the 100th of a second of the computer clock to do the calculation. So in this example, the random object that is created uses 10,000 as the seed value. Each time a random object is created with this statement, it generates the same series of random numbers. This may be desirable in some applications when you always want to produce the same set of pseudo-random numbers. So you could probably think of a better way if you really wanted it to be more complex than this. If you really needed something seriously to be more random than this, you could. We could use something else that's changing, I'm not sure. Perhaps perhaps not based on a 24-hour scale, you could just have it as a continuous scale, so you could take the current time and then you could like divide it or multiply it by like the continuous time so you take the number that's changing. So you take the hour, the whatever, because every time the 24 hours runs, we only have 24 hours in the computer clock, basically. So you could probably, well, if that's what it's referring to, then you could you could choose another parameter such as continuous time instead of just stopping it. So you could just you could run it on like a continuous scale instead of just like a scale that has that doesn't loop. So you could have something that just is continuous. So you could take both parameters, multiply them and divide them, and then get another value. So once one value doesn't end and the other one loops, and then add the extra values of the range, and that could maybe make it more random. Something that's continuous rather than something that just cycles over and over again. If you really needed something more random. I'm not sure when you would. Perhaps maybe to create some kind of verification codes, if you really needed it to be more secure. Well, that's pretty much it. So in the next part here, we'll talk about the load event. So we'll just talk about it a bit. We talked about it in the notes. We did some notes before we started doing the code examples. So we have here the load event. So in apps, so let's just go back to see what we said here earlier. We said the load event, when running an app, the app's form is loaded into memory and an event known as load takes place. So you've heard the name before, load, so this is basically where it comes from. To create a load event handler, simply double click the form in the designer. So we could do that. There's a way to create an object as well. We'll probably look at that later on. So there's the load right there. So it's private void form1 underscore load takes object center comma event args e again. Any code you write inside the load event will execute when the form is launched. So whenever the app runs, that's the first thing that happens. You could also kind of do that in the constructor, but you can also do it here. Perhaps this is before the constructor. Actually, maybe not. I think the constructor actually would be first, since that's down there. But usually anything that you want to happen right away, I think you can also put in here, in this constructor here. We'll talk about it also later on. We're going to talk about methods coming up first, which will probably talk about constructors. So you could show here like messagebox.form either here or here. Messagebox. You could show messagebox.here. Sorry, messagebox.show form loaded. Something like that, loading. Okay, so what else we have here? So the load event happens before the form is displayed on the screen. When the app containing this event handler runs, the message box is displayed before the form appears. Okay. So I think this one actually might be before the constructor. You can always test and see which one's first. Alright, one sec here. So any code you write inside the load event will execute when the form is launched. So basically before the form is displayed on the screen. So that's the tricky part. When the app containing the event handler runs, the message box is displayed before the form appears. Load event handlers are useful for performing setup operations. In tutorial, so in the lab we'll create an app that uses a load event handler to read items from a text file and add those items to a list box control. So hopefully I'll see you guys in the lab in the next video. So thanks for watching, guys. If you guys liked the video, you can like and subscribe to the channel to support the channel. Hopefully I'll see you guys in the next one. Take care.